Hello everyone. My name is Aditya Sahu and I'm a technical marketing manager with Infoblox. In today's video, we will discuss how Infoblox vNIOS can autoscale based on user-defined DNS queries per second and cache hit ratio using Ansible on Openstack. Making sure DNS queries are always resolved is crucial for enterprises and especially for service providers. DNS servers tend to get overloaded with multiple DNS queries during peak usage hours, which results in a low cache hit ratio, or more commonly known as CHR. Cache hit ratio is a measurement of how many DNS requests a cache can fill successfully compared to how many requests it receives. Low cache hit ratio results in more DNS queries being recursed for resolution, which further deteriorates DNS performance. This situation requires manual intervention of someone monitoring constantly and spinning up a new member when required. Using Infoblox vNIOS autoscaling through Ansible, customers can deploy vNIOS member on the fly as and when high DNS queries and low cache hit ratio is encountered. Now, let us talk about the solution and workflow. vNIOS autoscaling through Ansible solution is a combination of shell script and Ansible playbook. Shell script uses a combination of DNS QPS and CHR values to determine if there's a need for spinning up a new grid member. After the shell script has been invoked, it constantly polls and monitors the DNS member, and in an event when high DNS QPS and low cache hit ratio is detected, it triggers the Ansible playbook. Ansible playbook, which deploys a new vNIOS member on Openstack, uses Openstack and Infoblox modules. Now, coming to the workflow, once invoked, shell script monitors the specified DNS server for DNS QPS and cache hit ratio. Upon identifying a surge in DNS QPS and dip in cache hit ratio, it triggers the Ansible playbook, which in turn creates and initializes a new member, adds it to the grid, enables services, and finally adds it to the existing Anycast group. Now, let's quickly look at the demonstration. Let's first log into the OpenStack and check out our existing grid. Here we see that we have a grid master and two members running. Let's also log into the grid master and verify our grid status. This grid has two vNIOS members running DNS service. And these two vNIOS members are part of a name server group, Site A. Let's also quickly verify the Anycast configuration on these two members. As we can see, both the members are configured with Anycast IPv4 address and are listening on 32.32.32.32. In order to simulate DNS QPS surge, we will use DNSPerf tool. DNSPerf is an open source DNS server performance monitoring and testing tool, which is primarily used to measure the performance and breakdown threshold of DNS servers. Let's get DNSPerf started from a client machine. Since we have simulated a DNS QPS surge, let's go ahead and log into our Ansible server to invoke vNIOS autoscaling solution script. We are now logged into our Ansible server and we'll start our autoscaling script. Let's populate details of our DNS server, which we intend to monitor. This script will invoke the Ansible playbook if it detects DNS QPS higher than scale-up threshold and cache hit ratio lesser than the number specified. Let's verify our details one more time. Autoscaling solution will monitor this DNS server for 40 seconds to make sure that the DNS QPS surge is persistent and not momentarily. For the interest of time, I'll fast forward this video. And now we can see that the autoscaling script has invoked the Ansible playbook to deploy a new member. Member deployment generally takes 3 to 7 minutes and is totally dependent on the type of hard disk used. Deployment is significantly faster on solid-state drives or SSDs. Alright, after a couple of minutes, we have successfully autoscaled and have deployed a new vNIOS member, which is added to the grid. Let's now log into the Openstack environment to verify that we have a new member deployed. And here we see that Ansible has deployed a new member for us. We will now log into the grid to verify that the new member has been added to the grid and has also become part of the Anycast group. And here we see that Ansible has created, provisioned, and added the member to the grid. Let's verify the Anycast configuration of this member. And Ansible has also added this member to our existing Anycast group. Using vNIOS autoscaling solution, enterprises and service providers can make sure that DNS queries are always answered and a healthy cache hit ratio is maintained even during peak usage hours. Thank you for watching this video.